All right, welcome back. For today's tutorial, we're going to be talking about Docker and MySQL and how exactly to create a development environment that is persistent and works for each project. So typically when you work with Docker, it is designed in a way that it's actually temporary. And by being temporary, it allows it to not have any retention from instance to instance. This is part of the design for containerization that allows for all data should be stored somewhere else and all data on containers should be temporary. And the reason I bring all this up is we're going to kind of bypass that just so that we have the advantages of containers for our project and have a persistent system. So to start, we're going to go ahead and or actually run a command to see if Docker is configured. So from your command line of any OS, if you have Docker installed and configured correctly, if you type docker space ps, you should get a message like this. If it has any other type of message, especially an error, you likely don't have the Docker engine running. In Mac, you can tell by this little whale with all these little squares on top of it. And in Windows, it's similar with your system tray on the bottom. You need to get Docker installed and running. This may become a challenge if you're running earlier or less than Windows 10 Pro. It is possible to run in those OSs, but they're a little bit more difficult, especially like Windows 7 Ultimate. If you can run Docker, I heavily recommend it. So typically if you want to use a Docker system, typically when you need a MySQL environment, you want to install MySQL and put it on your actual OS. Well, with Docker, you can basically containerize that. And to do so, we're going to go ahead and create a new file. This file is going to be called Docker Compose. So Docker Compose is a system within Docker that lets you, as the name implies, compose multiple Docker instances and orchestrate them to do like environments and such. So for now, we're only going to have one, and I've already pre-wrote a lot of what the Docker Compose file should have inside of it. I'm going to go ahead and copy and paste this. So what this is essentially doing is you're identifying the version, and then we're declaring a services group, and inside of that group we're labeling what our actual Docker container label name is. In this case, we're just going to call it mariadb, and mariadb is similar to MySQL. It's a slight fork of it and has some optimizations and such. I usually prefer it if given a choice. They pretty much they work hand in hand, so it's the same difference essentially. There is a image declaration, and what images are is that Docker has a repository or a registry of different Docker compiled files, and this is somebody else preparing a MariaDB instance from Bitnami. They have a few Docker images that are just really slick and nice to use. The next line is describing what's called a volume. And volumes are essentially a binding of something within the Docker container to something inside your actual computer. So in this case, I'm binding a directory called docker/db to a directory within the container called Bitnami MariaDB. And you'll notice that there's a dot on the beginning, and that dot implies that it's a relative directory. And as you notice, we don't have a dockerdb folder yet. So we can go ahead and do so, because if we don't do this, it's going to give us an error that it can't find the volume to bind. And we're going to actually go ahead and comment this out, and I'll show you why we're binding the volume. So after recording this part, I realized that I didn't have a great example of showing you how exactly the volume mounting works. Let's just say that you should use it when possible in a dev environment. After that is environment. Environment variables are used in this case to actually produce a username, password, and database name. For now, I'm keeping everything super generic because it doesn't hugely matter in a dev environment. Obviously, a lot of this is bad practice when you're in a production environment, but because we're in dev, we don't necessarily want to get too complicated with login credentials, because the design of this entire system is to be ran only in your local environment. The next field is ports. So all MySQL-based systems have had the default port of 3306 pretty much since its inception. So 3306, you will get used to remembering that number. It's the default port whenever you run any sort of instance. And the reason you have ports is that when you bind a Docker container to a specific port in this style. As you can see here, we're considered the host, the computer that we're on right now, and then the container is obviously the image that we're going to be running, and the instance of that image. So by doing this, we're basically saying to bind our local computer to utilize the same port as what this container has. And obviously you can only have one port bind per container. So for a dev environment, this is perfect, but if you get more in a production environment, this can get complicated as far as how you do port binding and communicate between Docker instances. But we're not going to worry about that. I just want to kind of go over it real quick. And expose is not technically needed in this use case, but I typically have an expose port just because. And what this is doing is it's actually exposing 3306 as it writes here without publishing them to the host machine so that they can be accessed by link services. So all in all, though, that again is not necessarily needed in this case because we only are running one instance, but like putting in there. So now that we've created the Docker Compose file and our little terminal down here is in the Go sample directory, we're going to go ahead and run a command called Docker Compose. And if you do this without any commands, it's going to list a whole bunch of different possible things you can do with it. For the time being, all we necessarily care about is Docker Compose up. If you haven't built the services that are inside the Docker Compose, it will automatically do so. So this is pretty much all you need to do. So if we run Docker Compose up, you're going to see a new instance that it's going to be attaching called mariadb_1. And this name declaration is tied to how exactly the Docker Compose decides to label its instances and such. So in this case, it's spun up, it is initialized, and it looks like everything's ready to go. So we can go ahead and test connecting to it. But before we do that, I just wanted to show you, if you go over here to this window here, you can split the terminal into two so that we have a little bit more real estate and can type commands while this is running. And if we type docker ps again, you're going to notice that there's all this information talking about the instance. Let's go and do it again with a little bit wider. Especially its container ID, its image name, what the command was it ran, which is specified inside the image, how long ago it was created, how long ago the status has been up, and your port binds. And one thing that is always good to notice if you're trying to debug why Docker's not working is look at the port binding. You'll notice here that 0.0.0:3306 is bound to 3306 TCP on this instance. This is exactly what you want. If the 0.0.0 is not there, that means that it's not binding to your host and providing the port for, routing it into the instance. If this isn't happening, you could have some configuration issues and a few other possible debugging challenges you may have to look into in a future scenario. But everything looks good here. You can also run Docker Compose PS, which is virtually the same thing, but there's a little bit more details specifically with a compose environment as opposed to just the entire Docker system. So this is all running great. Let's go ahead and go to your SQL client. In my case, it's SQL Pro. And the steps to actually connect to a SQL database, they're all pretty close to the same thing. You're going to have some form of connection. And for the host, you want to put in the classic localhost. You can put the word localhost, but it's generally frowned upon, and the recommendation is to use 127.0.0.1 to connect to yourself, basically. We've configured it to have the user and password be username and password, and it also has the allow empty password option. And what that actually does is you can connect with root, and the root username is basically the super user of every SQL database. And because we have the allow empty password and we haven't configured the mariadb root password, we can actually leave this empty. And for the database, you don't have to do this, but we'll go ahead and do so. We called it db name. So if we type in db name and we haven't changed the port since it's 3306, the default, we can go ahead and say add to favorites. And that just creates a little instance over here, and we can just hit connect, and it just magically instantly connects. If you have challenges connecting, shoot me a comment on this tutorial and I can see if I can help you debug why. But your goal is to actually get connected. And once you're connected, on at least SQL Pro on the bottom left, this is how you add a table. In Heidi and in SQL Workbench, there's similar kind of interfaces, either like up on the top, just look through the different menus and you're trying to add a database or a table to your database. So in this case, we're going to create a table, just call it foo. And when I do so, it's going to default to what's called a structure. And what this is this is all the fields inside the database. By default, whenever you create a table, it starts with an ID field that is an integer, has a length of 11 bytes, is unsigned, meaning it can't have negative numbers. The key is considered primary, and that's an index declaration, which is used for like optimizing how it looks up the table. A lot of this I wouldn't necessarily fret over too much just yet. You can research it pretty easily. In the extra field, it says auto increment. This is a specialized extra field that's pretty much only used on the primary key when it's integers. And what this implies is that every time a table gets created, this ID field is incremented by 1. Well, I should say whenever a record is inserted into the table. And that way that every single row can be referred to by a unique ID. So it's a very primitive and simple way to create records that are incremented by numbers, pretty much how you would expect it if you were looking at a spreadsheet. For the next field, we're going to go ahead and just double click here, or depending on your UI, you can add a field essentially. But we're going to just call it name. That's a classic one. Instead of an integer, so that we only accept numbers, let's go ahead and do what's called varchar. And varchar is essentially any character, depending on your schema, will be like in this, the encoding is UTF-8, which means it pretty much supports any character that you can type with a keyboard. We're going to go ahead and make it something like 32, which means that the name can be up to 32 characters long. Null is a system where if the field isn't provided, there's a specialized SQL flag called null that essentially means that there's nothing there. In some cases it's good, but in our case, we're going to go ahead and disable that. And for the default, it's now going to have nothing, which means that the default field for this new field, the default insert is just going to be nothing, literally quote, quote. So it's a little different than null, but you can create a default like a foo. And what that means is that if the name field isn't provided when you do an insert, it's going to default it to the characters of FOO. So now that we did on that, let's go to content. A lot of database clients are going to actually start on this view, and you're probably going to have to go find the table fields field view. But in this view, you're going to see all the different records that you have inserted. So in our case, we have none. We can go ahead and add one either by pressing the plus sign or double clicking. And when we do this, you'll notice that ID by default is null, which you can actually just ignore because, as you know, the ID field is going to be auto-populated when the field isn't provided. And for the name, we're going to go ahead and say foo. And by doing so and pressing enter, this now created the record, and you'll see that the ID is now set to 1, which is the first value of any table, and the name is foo. And if we double click again and we go, bar, you'll see that it auto incremented the ID to 2 and bar. Just to kind of show you how primary keys, especially unique indexes, work, is if you put an ID of 2 and then we say test, it's going to error and tell us that the entry of 2 is duplicate for the key of primary. And that's because the primary key, which is ID, has a duplicate key. So we can edit the row and, let's put 3 and do it. Let's put 4, and you'll notice it accepts it. So you can provide an ID in some weird cases. That's not normally recommended. And for the last one, we're just going to say last, and you'll notice that it actually skips 3 because we specified 4, and it's taking the last index by the highest number and essentially incrementing from that point. So I do recommend whenever you create a database to bind a volume, in our case, DockerDB. And the reason being is that as you run this instance, it's going to actually bind the data directory and put the information into a flat file outside of the instance. This is just great when you want to repeat the instance every run. So as you can see, it's creating it, and now there's a data directory inside of Docker DB, and this has all of this information regarding the database. Now if we refresh, everything's gone, and that's because we've now created a new database instance. But we can easily get things back to where we were by simply putting in some fields and creating a field. And now that we've done that, we can stop, we can restart, and we can refresh, and the data stays there. So by doing so, our entire database instance is, the data that's inside of it is in this little field here. So you'll notice there's a DB field, DB name in here, and then there's the foo records for the table. So yeah, this is what I recommend doing. I'll put a gist, copy and pasting this field data so that you don't have to write it manually. But now that we have that all configured, you're going to notice that when you go into Git, you're going to have a lot of data here, right? And you don't necessarily want to version all this. So if we go into Go Sample, and we don't need to create a new file. You can see right here, it says .gitignore. If we open this file up, this file actually lets you specify what to do with certain special files. By default, Git ignores a lot of executables and library files and some weird test and output files. So what we're going to actually add to this is Docker DB. And the reason we're doing this is so that all of that data that's being, persistently stored for the database over here is now not versioned. You notice the moment I put this in and press save, this file gets edited and adds Docker DB. And that actually implies that all of the data and subdirectory info is ignored from being versioned. So with that in mind, we can version that. And we'll go ahead and version Docker Compose. And we're just going to say added mariadb instance. We're going to go ahead and commit. And we're going to push and press OK. And now we've versioned the mariadb instance onto the website. So if we refresh, you're going to see everything's here with the new commit. And with that, we've now finished getting a Docker environment set up with MariaDB inside of it. And we now can run MariaDB in a image so that if we're done with it, we can just simply hit cancel and can verify if it's alive or not. And that's all we're going to do for this tutorial.